So, a bunch of posts ago, I took apart a microwave oven, and you can check that out on my channel. And one of the items I pulled out was this turntable motor. It's a synchronous motor, 120 volts, 50, 60 hertz, 4 watts, and 4.8 revolutions per minute. So the idea is the microwave gives this turntable motor in your microwave a 115 volt supply, and it spins the food. But this can also serve as a generator, wherein you spin it and it should produce a voltage. So that's the first check I'm going to do here. I'm going to hook the leads up, and if you watch my multimeter and I spin it, come on, stay on there, stay on there. You can see I'm not spinning it at a constant revolution, but you can see that I'm generating a voltage. So I give myself a little, if I take this off and I spin it, ow! I get a little buzz there. Reminds me of a high school project where they had these generators in the classroom and the teachers talked you into touching it, and they spun it and you got a shock, and I was like, oh, that was okay back then, but it's not okay now. But anyway, so I'm going kind of slow, and you can see I'm getting a voltage there. If I spun it at exactly I don't know, 4 revolutions per minute, and I had a constant mechanical supply that kept it, I could probably get 115. So I'm thinking, okay, oh, this could power anything, right? You know, oh, I have a little generator here, but you'll see it's rated only for 4 watts. And I did the math here, and in general, if power equals voltage times current, and it's rated at 4 watts at 120 volts, I'm only going to get 3.3 milliamps out. So I don't think I'm going to be able to power a fluorescent bulb. I took this apart in another video, but I'm not going to be able to power this because it's 23 watts and it requires 0.33 amps. So this generator is going to be limited in what it can output without burning up or not having enough voltage and current to supply this. But what I did do is I found I took apart this LED flashlight that we have, and I'm thinking, okay, LEDs don't require much current to run, and look at this thing. Look at this concoction inside of here. It's got 3 AAA batteries that sit inside there in this fancy little case. You know, it's DC, but let's see what happens if I go from the center to the return and spin it. Let's see if I can do this without, hold on. I gotta somehow figure out how to hold that contact. Hold on. See that? The LED, because it requires very little current and very little power to illuminate, I'm able to power that with this. So I could probably solder some leads. And even though this is DC, it works on AC. And you can make your own little generator here for a light situation. Come on, baby. I'll probably burn the entire thing out. You can tell I'm not a professional. I'm just kind of rigging this up here. But I think you saw that. No. Come on. I knew I should have like gone full out here and soldered up some wires. How did I do this before? Come on. Oh. Well, if you were paying attention, you saw it earlier. Come on. Would I burn it out? See that? So the bottom line is, they won't tell you this. A lot of these, a lot of people on YouTube will throw you a circuit. They'll tell you the exact values, and you'll go off and make it. But if you don't really understand the principles, you know, half the stuff you try to replicate from what you learn on YouTube isn't going to work. So the bottom line is, this will work as a generator. It will make voltage and current, but you have to pay attention to what it can support in terms of power. And as I have demonstrated here, you can light an LED, and you can probably rig up something that where if you ran out of batteries or ran out of power, where you can use something like this synchronous motor to power a device that is rated for its wattage. So, you know, this has 115 volt input, 220 output to the lamp, which requires a certain amount of power because you're putting off a lot more heat, a lot more energy than what an LED takes. But yeah, so this works as a generator. We made 115, give or take, depending on how fast I spun it. And you can power an LED with something like this. Now, what I could do is rig up something that's constant, you know, rated RPM, 4.8, and I could like do the math, and I could figure out what I could power. You know, I could even hook this up to a transformer, a step up or step down transformer. We could do a lot of crazy things with this, and that might be a part of a future video. But the only point I wanted to make here is, this can serve as a generator for some lighting in an emergency, but you have to pay attention. You can't light this because it's requires too much current. Its power rating is too high. But certainly an LED you can power. So I don't know. I hope you got something out of this video. So please subscribe, and thanks for tuning into Kafkuba. Thank you.